Welcome back. Circuits. We can have an open circuit and we can have a closed circuit. When we talk about open circuit and closed circuit, it means that we're talking about switch. A switch, we've got two types of switches: open switch and closed switch. Open switch and closed switch. When a switch is opened, is when we switch off. When a switch is closed, is when we switch on. Switch on, close switch. Switch off, open switch. Switch on, close switch. Switch off, open switch. A closed switch allows electric current to flow. An open switch do not allow current to flow. Meaning when you open the switch, the light bulb will not glow. So it is very important to look at the circuits when we draw them. Make sure that a switch is closed to say that current is flowing. And make sure that the switch is open to say that there is no flow of current in the circuit. So, so for a current to flow again, you must make sure that as the switch is open, the cells are there, because without cells or battery, there will be no flow of current. Let's take, for example, the circuit of a torch. That's the one that they give you in grade 8. Because a torch has got a simple circuit. You connect the cells, connecting a positive side to the negative side. Negative terminal to the positive terminal. Remember, I showed you the positive terminal and the negative terminal. Your cell has a sign of a positive and a negative, which you know that positive represent proton and negative represent electrons. So, as electric energy is stored in the cell, the function of connecting the circuit with the cell is for energy to flow, because without the cell, the energy will not flow in the circuit. So you need a conducting wire, you connect it. And then you need a switch to control the circuit, the flow of current in the circuit. So as you are allowing it to control the energy in the circuit, after connecting, it will flow from, you will connect this component from one terminal to the next of the source of energy. Along the conducting wires, current will flow, and it will flow to the bulb. And when it reaches the bulb, it will move back to the other terminal of the circuit, because you'll connect it back. It will just be flowing and connected, as you have connected the conducting wire back to the cell or battery. It is moving from the battery through the conducting wire, reaches the light bulb, and give a light to the light bulb and flow back to the cell again. That's the path of electrons in a circuit. After that, you can ask yourself, yes, I have the example that in a circuit that we're using the one that gives us light. We've got a circuit that will convert energy, electric current. On your TV, it will give you, convert electric energy to light, to heat, and to sound. So you'll be having, when you watch TV, you'll no longer be having electric current. You'll be having light, heat, and sound. You remember the conversion of energy that you learned in grade 7. That energy is converted to heat, energy is converted to light, energy is converted to sound, energy is converted to what? Again, most of the things that we use is heat, sound, and light. There are other components that produce different things than light, that produce different things than sound and all those others. That one will get into it. So, the energy that you have connected in the circuit is being produced on the things that you're watching. In the past, when there was no electricity in all houses, we used to connect our TV on batteries because our energy was stored inside the battery. Electrons were stored inside the battery. We will learn more about these electrons being stored in a battery in grade 9, whereby you'll also understand that you can make your own fruit cell by connecting a lemon to produce light, or connecting a potato to produce light, meaning that even lemons contains electrons, even potatoes contains electrons. So those electrons inside the fruit cell, fruit, can give you light. When I tell my learners, ma'am, you're lying, you're joking, you're not, it's not true. How can a fruit contains electrons? You'll learn more about that in grade 9. Let us keep that for the future. But understand that a circuit is needed for a system to function. We call it a system. That's how electric energy is transferred in an electric circuit. So these conducting wires, we have got the ones that, let us look at those different components: conducting wire, a switch, a battery, and a resistor. Now I have introduced resistors so that you understand. Conducting wire, some travel a long distance. Some conducting wires are traveling over a short distance, and they are different in sizes. When we talk about conducting wires, is the materials through which charges can flow. Remember, charges, we are talking about electric charge, electron, which jump from one object to the next, meaning that they will jump from the cell to the conducting wire to the light bulb and back to the cell. That's what electrons are doing. So as conducting wires are part of the component of the circuit, they're very, very important to understand that we've got the ones that carry electricity over a long distance. Those ones that they build big pylons, big pylons. And those ones that we must not play under because they are very dangerous. You can ask yourself that some places they are close to homes, they are close to shelters of people. Those which are close to where people pass, usually when they build those pylons, they have made a wire around them to block the electrons not to go to the ground so that people will not be electrocuted. So, conducting wires travel over a long distance. Because our power stations are not close to where we're staying. They are very far. That's why electricity can be generated from Cape Town and be transported all over South Africa and even the neighboring countries. It is because of the big conducting wires that we call conducting wires that carry electricity over long distances. And the ones that are in your house are the conducting wires that are carrying electric current over short distances. So in the next video, we'll learn more about the components of the circuit as we continue with our lesson. Thank you very much. See you in the next video.